First, what I want you to do is look through these covalent formulas and names and see what you see. Do you notice anything? Just think about what kind of patterns you see. Okay, so most people say, well, I see everything ends in "ide," just like ionic compounds. And again, the "ide" is just to tell me these things are not just mixed together. They are actually bonded together in a chemical compound. So the difference in sodium and chlorine and sodium chloride, right? Deadly versus need to live. That's what that "ide" is telling me. It's not just carbon and oxygen, it's carbon dioxide. It's a compound. And so what else did you notice? Maybe you noticed that some of these have these little prefixes. And I'm cheating on y'all with this dihydrogen monoxide, because really we don't say this. We do not use this. We just say water. So there are a few common names you'll need to know. 3 common names to know. You ever want to scare a little child or something, and that's mean you shouldn't scare children, but you could tell them they're drinking dihydrogen monoxide and they'll be like, oh my gosh. I want to say that at some point in our astonishingly recent history, there was a governor or a mayor of a town that somebody pranked and said, like, oh, there's dihydrogen monoxide in the water supply. And he was like, oh, we gotta have a task force for this and like give a press conference on it or something. I'm not sure if this is true, but it was just like a urban legend that I heard. So I think it's kind of funny, but you know, the moral of the story is we should have more people who are more scientifically literate in positions of power. That's all. I'm not going to get political, but that's all I'm going to say. 3 common names. We got to know water is H2O. You need to know ammonia is I almost put C because I'm thinking about my other one. NH3. Ammonium is NH4 plus. Ammonia is NH3. And then I want you to know methane. Now we're going to learn methane later in organic chemistry if you're in a class where we do cover organic chemistry. But right now just know that methane is CH4. Okay, so we got some prefixes here, and the prefixes are telling me how many. So like di means 2, so 2 oxygens, 2 hydrogens. Tetra means 4, so 4. Deca means 10, right? And mono means 1. So kind of looking at these rules, and notice that if there's only one of the first one, we didn't put mono here. So no mono on the first element. But do I put a prefix in the first element if it's not mono? Yes, I do. I just don't write mono on the first one. It's just like a shortcut. We just have a convention of writing it. So what are my prefixes? All you need to know to do covalent writing and naming is how many of each element to write. That is it. And then if you want me to write 2 oxygens, you put a prefix in front of oxide and make it 2. If you want me to write 4, you put the prefix for 4 in front of the element name. That's it. Change the ending to "ide" on the second element, you're done, right? No charges, because these are covalent compounds. They're sharing their electrons. They're not transferring their electrons, so they're not becoming charged. No ions, no charges, no Roman numerals, nothing like that, okay? Just what you see is what you write. What you write is what you see. That's it. Make it easy. So this is kind of giving you this. I'm just going to amend this. We do not put mono on the first. We don't say mono carbon dioxide. Y'all know carbon dioxide. Well, I have had in the past where I put carbon dioxide on a test and my future nurses have gotten it wrong. Y'all have to know carbon dioxide is CO2. Okay, it's like critical that you know some of these things for real life. So what are my prefixes? We got mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. The first, I think tetra is probably the hardest one to remember. The rest of them are just like your geometric prefixes. And I think it's not bi, but di here with a D. And then so tetra is kind of the hardest one, I think, for most students to do. I remember hexa because 6 has an excident and hex has an excident, so we can remember that. And then hepta is the other one. If you're thinking about the difference in hexa and hepta, sometimes it's confusing for students as well. But put those in your little list of memory. You'll just do some practice with them and get them real fast. So let's just practice. This does not take a lot of teaching, so let's just get into it. I'll write the names for these. Now, what do we got? Well, how many silicons are there? There's one. So we're going to say monosilicon? Nah, we're just going to say silicon. Silicon, not silicone. Silicone is a plastic material. Silicon is the element. How many chlorines do I have? 4. So what's the prefix for 4? Tetra. Tetra. And then I do need to change the ending of that last element. Don't change the ending of the first one, just the last one. All right, look at the next one. How many P's? So di, and what is P? Phosphorus, not potassium. Whoops, I spelled that wrong. Phosphorus is just for us. When you're just talking about the element phosphorus, it's just US, not OUS. So phosphorus is just for us. 5 is pent, and you can say pentaoxide or pentoxide. It doesn't matter. You can write the pentaoxide if you want to. Some professors get real weird about the pentaoxide. I just say pentoxide. It's just easier. If I can write less letters, I want to. I got 2 chlorines, so I've got dichlorine. Notice that I'm not changing the ending on the first element. And then 7 is for hepta. And you could say hepta or heptoxide, whichever you want. They are both correct. That's it. So, this is going to give you a nice little chart of all the ionic and covalent that we've done so far. We're going to get into acidic in the next video.